In this video, we're going to look at variable forces. Up until now, all the videos in this section have been about constant forces acting on an object. Well, what if the force varies? And that's what we're going to look at now. How do we handle the case of a force that varies with time or varies with position? Okay, so let's say a particle of mass 4 kilograms is acted upon by a force, and what we want to find is its velocity if the force is given by 12t minus 3t squared, where t is time. We want to find it after 4 seconds if, if its initial velocity v of 0 is 2 meters per second. So I apologize if that's not worded very carefully there. Okay, now F equals ma. Our force is 12t minus 3t squared, and that's equal to the mass times acceleration. The acceleration is written as a as dv dt. Its mass is 4 kilograms, so it's 4 times a, or 4 times dv dt. Okay. Well, if we divide through by 4 on both sides, we get 3t minus 3 on 4t squared is equal to the dv dt. And if we were to split the differentials, we would get essentially what I'm really doing here when I do this dv is what I really mean is dv dt integrated with respect to t. Okay, and the same on the other side, integrating both sides with respect to t. Okay, so the integral dv is the integral 3t minus 3 on 4t squared dt. All right, and okay, on the left-hand side, we end up with the velocity, and on the right-hand side, anti-differentiating that, we have 3t squared on 2 minus t cubed on 3, which means the 3 disappears on the top, so we're left with 1 on 4t cubed plus a constant of integration. And we're told that at t equals 0, v of 0 is equal to 2. So if I put t equals 0 in here, all that disappears. V of 0 is equal to 2. And that tells us the constant must be equal to 2. And so our velocity as a function of time is 3 on 2 t squared minus 1 on 4 t cubed plus 2. Okay, and then finally we were asked find its velocity after 4 seconds, if you remember, after 4 seconds. So we now have the particular solution, v of t, that's this object here. Now let's substitute in t equals 4. We have 3 on 2 times 4 squared minus 1 on 4 times 4 to the power of 3 plus 2 gives us 10 meters per second. So t equals 4 seconds. The velocity of the object is 10 meters per second. Remember, it's a variable force, and that will be acting to change its velocity. Okay, let's find its velocity if the force is given by 3 minus 2 times x, its position. So the force now is a function of position, and we looked at videos about 4 or 5 videos ago. We looked at that situation where we said for where force is a function of position, we could use this object here, d dx of a half v squared. It used the chain rule, which gave us v times dv dx. So if you look back 4 or 5 videos there, that was the case. Now, and we're told that x equals 1 when v equals 2. Okay, x equals 1 when v equals 2. So we're given a boundary condition there. The force is 3 minus 2 times the position variable x. So that's equal to the mass is 4 kilograms, if you remember. So it's 4 times, and this object here for when acceleration is a function of position, we use d dx of a half v squared. So what we write now is, let's divide through by 4. So we have d dx of a half v squared is 3 on 4 minus 2 on 4 gave us x on 2. Okay, now let's anti-differentiate this. So we're integrating with respect to x, a half v squared. We're integrating the right-hand side with respect to x. You can see that there. And we have the integral 3 on 4 minus x on 2. Well, anti-differentiate this, we're left with a half v squared. 3x on 4 on the right minus x squared on 4 on the other side, plus a constant of integration. And we're told that when x equals 1, v equals 2. So let's substitute v equals 2 on the left here. And where the x is, let's put x equals 1. Okay, we've got a half times 2 squared, so that's 4 times a half. That's going to give us 2 over here. 3 on 4 minus a quarter will give us a half. plus our constant of integration, so 2 equals a half plus c, and that tells us that c must be 3 on 2, because 1.5 plus a half will give us 2. And so what we have now is a half v squared is 3x on 4 minus x squared on 4 plus 3 on 2, our constant of integration, to give us a particular solution. Let's multiply through by 2. We get v squared is 3 on 2x minus x squared on 2 plus 3. Let's take the square root of this, and we'll take the square root of 3 on 2 times x minus x squared on 2 plus 3. We were told that v is plus 2 when x is 1, so we'll take the positive solution here as our answer, positive square root, and we're left with 3 on 2x. So we know that at x equals 1 we have to get plus 2, so we're taking the positive square root. Alright, that's it then.